So here in this question it states that Jack Fox has recently won this amount in Las Vegas and is trying to determine how to invest his winnings. So here are the 5 different options that he has, and this is the summary of inflows and outflows. If he invests $1 in the year 1, then at the beginning of the year 2 he gets zero point 0.5 in return, and in the beginning of year 3 he'll get another zero point 0.8 in return. Similarly, for option 2 in B, he can invest only at the beginning of year 2 and will get a return only in year 4. Invest $1 in year 2, he gets 1.25 in year 4. Similarly, these other schemes. Alternatively, not this, okay. Entries of double arrows in the table indicate times when no cash inflows or outflows can occur. At the beginning of any year, Jack can place money in money market account that is expected to yield 8% per year. So he's talking about another options which is not listed here, which is expected to yield 8% per year. He want to keep at least 50,000 in the money market account at all times and doesn't want to place any more than 500,000 in any single investment. How would you advise Jack to invest his winnings if he wants to maximize the amount of money he'll have at the beginning of year 4? So, this line tells you the objective. How would you advise Jack to invest his winnings? So, he has to invest his winnings all over these years so as to maximize the amount of money he will have at the beginning of year 4. So let's look at it. At year 4, with these 5 options, you will have 1.25B, 1.35C and 1.13D. Because this money, if you have a doubt, like what about the money that was invested in A? Well, in that case, the money that was invested in A in the year 1, if any amount is invested, then it will have given its return over year 2 and year 3. In year 2, the return amount would have been reinvested in any other investing option. Similarly, the return amount in year 3, like 0.8 and 0.1, 1.27, will be reinvested in some other scheme. So in the year 4, we'll have this as the return. Now, it also talks about money market scheme that is expected to yield 8%. That means there is one more scheme called money market, and it can be invested over all the years. So let's say money market in year 1, money market in year 2, money market in year 3. If this is invested in year 1, it will be -1. Because it is expected to yield 8% per year, the return would be in the second year 1.08. Similarly, for M2, if money invested in year 2 is -1, then in year 3 the return amount would be 1.08. For M3, similarly, if the invested amount in year 3 is -1, return amount would be 1.08. So what can be the decision variables here? Decision variables would be amount of money invested in all these schemes is our decision variables. And what would be the objective? Objective would be to maximize the amount of money he will have in the beginning of year 4. So in the beginning of year 4 he will have 1.25B, 1.35C and 1.13D and 1.08 M3. Let us write down the LP for this problem. First, so the variable would be let amount of money invested in A is equal to A, in B is equals to B, C is equals to C, D is equals to D, and E is equals to E. And M1, let M1 represent amount of money invested in market account in year 1. Similarly, M2 is for year 2, M3 is for year 3. Now, our objective. Our objective is simple. If amount invested in B is B, then return will be 1.25B. So 1.25B plus 1.35C plus 1.13D plus 1.08 M3, 1.08 M3. Now our objective is to maximize this return. And what are our constants? Our constant is that he wants to keep at least 50,000 in the money market account all his time and don't want to place any more than 500,000 in any single investment. That means A, B, C, D, E, A, B, C, D, E can be greater than equals to 0 but has to be less than equals to 500,000. Similarly, for same condition, greater than condition for M1, M2, M3. But he wants to keep at least $50,000 in the money market account. So the minimum amount for this would be 50,000. Apart from this, amount invested A, B, C, D, E, comma M1 plus 3, they also be greater than equals to 0. And amount invested initially should be equal to the total investment amount. That means at no point of time he should have money which is not invested. His whole idea is to make it maximum. So he has 1 million amount of money, and this sum of invested amount should be 1 million. And what is this? How is this amount calculated? It would be A plus C plus E plus M1. Similarly, for year 2, the net amount should be 0 because all the amount which is returned should be reinvested. This to a return should be reinvested into available options. So if the money received is 0.5A and 1.08 M1, it should be invested in a very appropriate amount in B and M2 such that it can get higher returns. Now coming back to forming these constraints in the LP, we'll have A plus C plus E plus M1 should be equals to 1 million. This is the year 1 cash inflow constraint. Similarly, for year 2, it will be 0.5A plus 1.08 M1 minus B minus M2 should be equal to 0. Similarly, for year 3, it should be 0.8A plus 1.27 E plus 1.08 M2 minus D minus M3 should be equal to 0. Now, our aim is to convert this LP to the spreadsheet problem. So in the spreadsheet, I've created this template. So this is our decision variables, amount to be invested in each options, and make them as gray. The minimum here is 0, 0, 0, 0, 0, and the maximum is 50,000. This constant 50,000. Extend this to all. Sorry, maximum is 500,000. For M1, M2 and M3, the minimum is 50,000. Now, this is our amount invested in year 1, that would be sum product of this multiplied with this. We will make this constant, and for this we will make the rows as constant. We'll extend the formula to other rows. Just check, yes. And our return is extension of the same formula. Is 1.25, B 1.35, C likewise. So here our investment amount should be 1 million. For year 2 and 3 should be 0 and 0. All amounts should be reinvested into other options. So this is our objective set. Make this net as good. So let's put the constraints. Solver maximize the return by changing variable cells, amount invested, subject to the constraint. These values should be equals to this value, and this amount invested should be greater than the minimum amount. This amount invested should be less than or equals to the maximum amount, and say okay, make result to solve. So this is our final solution with this as the maximum investment, maximum return on investment of 1 million through varieties of schemes.